you'll see on your video notes what is factoring. That's what we're talking about today. Factoring. Okay? And you did it last year, whether you remember it or not, where you took something like 30 plus 40, you found the GCF of 10, and rewrote it like this, as 10 times 3 plus 4. You did, even if you don't remember it, you did something like this last year. So what we can say that factoring technically is separating a polynomial back into a product. So product means we're looking at that multiplication, right? So we took this two-term polynomial here, and we turned it back into a product. So we've been doing this for a while, right? Distribution with our polynomials. Again, like everything in math, you learn how to do it, and then you learn how to undo it. You know why? You learn how to undo things. Sometimes you need to undo it, right? And it's going to give you that fluency, numerical fluency and flexibility to problem solve. And you're going to love to be able to factor when it comes to solving quadratics, because the quadratic equation looks like this. I think. It's been a while since I used it, but yeah. That's the quadratic equation. It's a lot of work. If you can factor something, you can look at it and get an answer. So I like to solve by factoring. Now, some things we cannot do anything to separate them back there because like there is nothing to factor out. And for that, you would call them prime. So they can't be factored, yeah. Like in a prime polynomial, the only common factor is 1, which if you divide a bunch of stuff by 1, what happens to it? Nothing, right? So you can't do anything with it.
Sound what 4 is?
All right, so let's look at like number 1 on your examples, on your PDF notes. It's 3x plus 12. So when I look at one of these expressions, I'm looking for the greatest common factor first, or the largest thing I can divide everything by. So if I got a 3x and a 12, I can divide both those by 3. And I just imagine like sending the 3 out of there, man. Get out of there. So if I pull a factor of 3 out from 3x, what am I left with? X. And if I pull it out of the 12, what am I left with?
4.
Plus 4. And one thing you can always do, like don't actually do it, just imagine it maybe. Don't just imagine doing it, imagine actually doing it. But if we distribute, there's my 3x, there's my 12, right? I wouldn't like actually distribute to check it, but like I'd think about if I did distribute, what would my answer be? And it should be what we started with. So my answer, 3 times x plus 4, have I changed the value of my expression? No, it's still the same expression, it just looks different. Okay. So again, before we distributed, now we're like undoing distribution. I want you guys to try out number 2 on your own, please. That's 7y minus 7. Find that GCF and factor it out. 7. So I'm factoring that out. I'm left with a y minus 1. We good? Okay, I'm going to do 3. And then you're going to do 4. I got an 8m plus 36n. So don't worry about these variables. No big. Any variables in common?
8.
No, variables.
Oh, no.
No, so I'm just going to ignore them. I've got an 8 and a 36. They do not have an 8 in common. They have a 4 in common. So if I factor out a 4, I'm left with 2m plus 9n. And then one check, if you look up in here, if there's a common factor, then we did not get the greatest common factor. So looking at 2m, 9n, there's nothing else in common, nothing else to pull out, right? So just right here, boom, that's where I'm at. All right, y'all try out number 4. So, who's got a greatest common factor for me here? All right, Oliver.
5.
5. And if I factor it out, what am I left with?
X plus 6y.
There we go. I'm seeing that as well. Remember, you can always try to distribute it and make sure you get back to the same thing. All right, turn the page in your PDF notes and you'll notice things get a little more. Okay? No, it's all good, though. We are going to jump to number 9. It's no big deal. NBD. So I'm looking at these two terms in my binomial here. Okay? I've got a binomial. And I like to focus on coefficient first. So 15 and 30, what's the greatest factor of 15 and 30? 15. Then I'm looking at variables. So everybody understands a squared means a times a, right?
Yes.
So there's 2 factors of a. So I'm asking myself, how many factors of a do they have in common? The answer is 1. They both have at least a factor of a, right? They don't have to both have an a squared. Because I can rewrite a squared as A times A, correct? So they both have at least one factor of A. Do they both have a factor of B? Yes. So I can divide both terms by 15 and A into B. And if you recall, what does the quotient property allow me to do with my exponents when I divide? Subtract, right? Because they cancel each other, right? So 15 divided by 15, 1, right? What's A squared divided by A? It's 1 factor of A remains. B divided by B? 1. So I'm not doing times 1 times 1, right? 1 times 1 times A is just A. Then I got a minus. Let's do the 30 divided by 15 is what? 2. A divided by A, B divided by B, those cancel. Here's where I'm at. 15AB times A minus 2. 15AB times A minus 2. And then if you want to check it, right? Distribute and see what happens, right? There's an A squared, cool. 15A squared B. Here's a negative 30AB. It checks out. I want you guys to try out number 10 on your own, please. And remember, just get it, like, don't be afraid to get it wrong. Get it wrong. It's cool to get stuff wrong. Okay? Then number 10, what's the greatest thing, what's my coefficient that I can? 8, okay, I agree. How many factors of B do they both have? 1. How many factors of C do they both have? 1. So I'm going to factor on, well, they all have only at least 1, yeah? So I'm going to factor that out. I get 2C plus 3. Cool. What's kind of tricky about these is like there's nothing to do like to show more work. It's like you gotta just think about it, right? Okay, let's get a little crazy. Let's jump up to number 18. Oh yeah, dude. The crazier these get, the better. You should have seen. I did all these. I went back and did all the notes after like we did it and stuff. I was just smiling the whole time I was doing this. Okay, so when there looks like a big problem, we break it down into smaller problems. That's how we roll. So looking at the coefficients, what's the biggest number I can divide everything by? 6. Okay, we'll throw that there. Then looking at my A's, how many A's do they all have? At least 2. Right? There's A squared be our limiting factor of A's. And then B's, they all have at least 2. So do you see how I got that GCF? This number is the biggest number I can divide everything by. Okay, let's work on our first term. Right? We're pulling it out of there. So, 12 divided by 6? 2. A to the 5th divided by A squared? A cubed. B squared divided by B squared? 1 and done. All right, so it's not 0, it's 1, but times 1 means we don't have to. Okay, next. 36, negative 36 divided by 6? Negative 6. A to the 4th divided by A squared? A squared. B cubed divided by B squared? B. Okay, 6 divided by 6? 1. A squared divided by A squared? 1. B squared divided by B squared? 1. So we actually have to put a 1 there, right? Because it's all 1 times 1 times 1. It's not?
6 times 8.
So it's minus 1.
I have a negative 1.
Yeah. Yes.
GCF when you
Greatest common. It's kind of cool. Greatest common factor is cool because factors are small, right? What you can divide by. It's like the biggest small thing. What's the biggest small thing you can do? Yeah.
We're basically making the zombie problem now.
Kind of, yep.
We got some blankets and some apples.
You can always check it by redistributing. I want y'all to try out number 24 on your own, please. Hey, while you're doing that, I'm going to do number 13 as fast as I can. Ready, set, go. Done. Woo! Yeah, it's prime. That was.
Is that called a prime by
Hey, this is a transformer's favorite type of polynomial.
Because that one's an octopus.
Because not octopus, Optimus, man. Get your transformer game tight, man. All right, I've got a GCF of 3A, B squared, C. So let's hold up right there. Everybody got that at GCF?
Yeah.
Break it down to smaller problems. I'm only focused on the first part of my trinomial here. So 3 divided by 3 is 1. A cubed divided by A is A squared. B squared divided by B squared is 1. C divided by C is 1. So I'm not going to A squared there. Minus. 9 divided by 3 is 3. A squared divided by A is A. B cubed divided by B squared is B. C squared divided by C is C. Okay, third term, plus 15 divided by 3 is 5. A divided by A is 1. B to the fourth divided by B squared is B squared. C cubed divided by C is C squared. You can always test this by distributing. You want to know what's triggering me a little bit though? This is 6th degree. This is 7th degree. This is 8th degree. That polynomial should be in standard form, bro.
Oh my God.
Yep, it's a little scandalous.
Brilliant.
It's a little scandalous. But it doesn't change what we do to factor, yeah.
When it's like incorrect, does that still have to be in standard form?
No. So, cool. This is going to help you solve quadratics much easier. If you can factor a quadratic, you can pretty much look at it and have an answer. If you can't factor it, you got to put in values. You got to put in values for that and then simplify that, okay? Let's get after it. Your homework's the 3rd page of the PDF.